So we will learn a lot about LLMs in a visual guide, and we will code and train our own small LLM that's gonna actually work. And we will also train a small image autoencoder, so you will learn a lot in this video. And I made it all as simple to understand and follow as possible. So if we have a sentence, hello, how are you today? Then the next token has 60% probability, almost 60, to be I, and then these are the rest of the top 10 tokens. So this is a real language model, Qwen 3 0.6b. And then let's take a look at this. So how does neural network know the position of each token? Which token is first, second, third? So it uses this rope. And you have position here on the left. This is the first position from 0 all the way to 500 something. And if we have, let's say 32 dimensions maybe, then we have these frequencies. So each of the positions has this vector that's just an array of 32 numbers. And look at the values. This is just hard-coded by engineer. This is not learned. So we will multiply this position embedding with, if you know what queries and keys are in transformer. If you don't know, it's okay. So that way, by multiplying these vectors, we will know the position, or LLM will know the position of this token. Because every single one is different, you see, every one is different. And now the question is, why do we need the entire vector to store position? Why not just a single number? For example, position 100 gets this number, or position 200 gets a number, not whole vector. That's because there is a lot more information in a big vector. So, you know, neural network is going to multiply this vector with a bunch of different like weights and keys and stuff. So it basically has more processing and more thinking. So this vector, let me first show you what it does. So it can store, for example, if you have a vector for 100th position, neural network can learn that it's close to the 98th position, but it's far from position 7 up here, and it's somewhat close to position 70. So this vector, it basically has just more numbers, and it's being multiplied with more stuff, more weights, more keys, more weights, more numbers. So it's like more processing. And even though these numbers are not changed, they are always same, they are fixed, the weights that are multiplying them, or keys or queries, they can change to extract proper information. So they can change to see that if, for example, it's all high values here, then it's some low number, and then if it's like high values here, but then low values here in these dimensions in the vector, then it's maybe some higher dimension, or they will learn. So basically here they have a lot more numbers to process, to multiply with, more weights, so neural network has more processing power and places to learn things and to adjust weights. So when I say weights, in reality, rope is applied directly to the query and key tensors. So first we have some input, convert this to query, convert the input to key with the weight matrices, and then pass that through rope. So query and positional embeddings, which is our whole like big matrix of a rope, this big matrix. I will not go into detail here, but it basically splits entire query head into these pairs of dimensions and then multiplies these pairs with cosine and sine. So does the rotation, but this is for a different video. One cool thing is this can easily be extended after the training. So neural network actually is learning that these weights can have this pattern. So after the training, you can extend this pattern further without even training it. And LLM will see the pattern and know. Now I want to try training a small LLM. So I just have this I will leave this code below. I'm using Hugging Face small LLM corpus and tokenizer because they are good for small LLM. And I'm using RTX 4090. I rented it from Novita AI. It's cheapest. They're cheaper than Vast AI. If you go the spot instance, let me see here. I wonder if I should increase batch size or sequence length for better and faster convergence. Let's max out sequence length first, and then I'm gonna go to batch size. 24 is not a good number. Why do I even have 24? So this should be 32. And these are all ugly numbers, by the way. They should be powers of 2. I don't like these numbers. They're not powers of 2, but I'll leave it like this for now. We got CUDA out of memory for this cross entropy loss here. So I reduced batch size to 16, and this looks like the training will be 3 hours, 2 hours. Okay, it's going down. I also want to save intermediate checkpoints. Loss is kind of big, 9, but I guess it's going down also. I want to check when is it going to be like be able to generate comprehensive legible text. GPU memory use 60%, so we could increase some things as well. We are underutilizing it. Cursor is recommending that I increase batch size to 24. That's okay, I'll accept that, but I will not accept, actually here, reducing gradient accumulation. I don't know, okay, let's accept that as well, but I will not touch this. This is an ugly number, and this is buffer size for streaming. Why? Why do I need this? I'll just leave it like this. You see, we have GPU utilization. I guess compute is high, but memory is not as high. We should increase the memory utilization then. Oh, we got 99 on GPU. I think this is good because this will not crash. Like memory would crash, but GPU wouldn't crash. GPU compute utilization. Loss is already very low, 1.8. We are just 7 minutes in. So if you didn't notice, I have a run2 file that I'm modifying, and this first version is just running here training. Validation loss is higher though, 3.9. Why is it so much higher? Is it overfitting? But I think it's seeing data only once, so it doesn't make sense. Okay, here is 2.4, a bit lower validation loss. Also, I asked Cursor to tell me how I can save this to checkpoints, to Hugging Face. For example, this is just 1 hour, but if it's like a lot more hours, then we want to save intermediate checkpoints in case something crashes. So it was able to program this, to code this, so I just put my repository name when I make it here, and it has this checkpoint manager here, which is very nice. Let me reduce this. We don't need this big. It's just checkpoint manager. For now, I will reject this. I think it's okay. I will just let this training run finish for now. And while that's going, I want to do something fun with a different GPU, maybe with some images. So I'll show you. I'm using this Novita AI, and they have the cheapest 4090 GPU here. So if you go here on demand, you go to spot, 50% off. So they have the cheapest. Look at this, 50% off for 5090 as well. This is the new Blackwell architecture. This has FP4. This is crazy. I'm gonna use this as well. So 4090 is 0.18 dollars per hour, but look at Vast AI. This is considered to be cheapest, but it's actually more expensive. So the trick here is they can take this from you when they need. So this is for extra capacity, but you will get 1 hour in advance notifications. So it doesn't hurt us at all. And you can always transfer your data, but our experiments take less than 1 hour, and they will probably not even need this. So we will be able to use this as much as we want. So Novita gave me some credits to use for free and just to mention them in the video, but they are actually cheapest. I'm not just mentioning them. And so if you wanna get some credits, use Novita, you can use my link below. I get 10%, but they are actually cheapest. This is the reason why I'm telling this to you. Their best service. So if you use my referral link, 10% goes to me, you lose nothing, it's just Novita's money, they gave it to me, so I can buy more compute and I can make better videos. But you can use a Vast AI or whatever other service you want. I'm just using Novita because it's cheapest and it's pretty reliable. I didn't have any problems. So I want to show you 25 cents per hour for this best GPU. And the cheapest one is 27 cents per hour. And it's not even very likely that you will always get this. So 33 cents per hour is usually. Our loss is substantially down, 0.15, but I wonder what the validation, it's also very low. So this is a good sign, although I have some memories. The loss shouldn't be this low. I think loss should be a bit higher, but I'm not sure what's happening here. But we'll just wait for the full training run and see. And it should be finishing quite in like 38 minutes. So when you decide which GPU and which service you will use, you will just deploy. I'm gonna use this image. You can change template here. I'm using this template in my case, and I'm gonna go next, choose the spot, 50% off, and deploy. We are at 50% and loss is quite scary. What is this? It's too accurate. Is this training too much? What's happening here? So if you want to connect, then you need to click here, connect. You can copy this and run in terminal, but you should ask ChatGPT. It will lead you step by step. You need to generate the key and then add this to the settings, and then you can connect. This is just SSH connection. It's same for every SSH, remote SSH. So I will copy this part after root and put that into host name here. This is the port. And then I should be able to connect to this. If I refresh here, I should connect in new window. And you will need this extension, SSH extension for VS Code, and then just follow instructions of ChatGPT. You need to look for this connect to host, and then configure settings, configure this one, and then you get this. So now that I successfully connected, we need to wait a bit for this to open and do all of this stuff. Okay, now it's connecting. It needs to download some VS Code stuff. So I'm gonna go back in the folders into workspace. You wanna go into workspace and then open that. Most of the GPU providers will save everything you put into workspace. So you wanna create files in the workspace, because if you create them elsewhere, they will get deleted when you shut down the GPU. They will not stay in the memory. But in this way you can shut down GPU, and if you don't destroy the instance, it will still remain in workspace. This LLM is 80%, so I'm gonna go here and say into different GPU, I want to create autoencoder. First download cipher, this is dataset images from Hugging Face, not too many. I gave it the URL. So autoencoder will just take image, encode it into smaller vector representation, and then from that smaller vector representation, encode it back into the full image. So you use this if you want to do something with images. You need this small latent representation. You don't need every pixel value. If there is a bunch of blue sky, you don't need every pixel. You need just some latent representation that's showing that there is a bunch of blue sky in like this half of the image. But you don't need every pixel. And so you can use this latent to process this in LLM or visual model or whatever. So it wants me to search this internet. I'm gonna allow it. You can just Google CIFAR10 database, and it will, you can copy the link from Hugging Face. Just Google Hugging Face CIFAR10. It made me run some of these commands, this agentic. So I'm using this free cursor LLM. I don't even know which LLM it is, but it's working. So it's just telling me to write this command. This is really nice. Like, we can vibe code. This is such a good thing. I started like using vibe coding heavily late, like week or two ago. I knew about it, but I didn't have a need for it. But now I see like how good it is. Maybe it's gotten even better now, recently. So this is downloading, and you see it sees the console, it sees everything. This is so cool, it's so good. Agentic tools. This is crazy. I can imagine all of these like software products and services, platforms are gonna start pumping out now features like crazy because they can vibe code everything. Now we can see it downloaded a few of these pictures, maybe 20, just 20, 30, 40 pictures. Inspect. So it asks me if I want to inspect the data. Let's see what it means by that. Vibe coding is the best thing ever. I didn't expect it to be so good. So like even right now, 2025, it's so good. I can forget about code. This is crazy. I can just ask how many images are there. And then it's gonna give me commands. And I can run all of these commands safely because it's in this environment. 50 images, okay. Proceed with, okay. Is this too few for Autoencoder? And I don't even know if I'm logged in into Cursor because this VS Code is running in this GPU computer. So I don't know if I'm logged in, if this is free or this is my login. Anyways, I told it I want 1,000 images. Now you have 1,000. Oh my god. This is so good. I can't explain how good this vibe coding is. Let's continue with Autoencoder. It made a plan. So prepare dataset. Okay, let me run it. Then define autoencoder, train the autoencoder, and visualize results. I like the plan, very simple, very good. Now it's installing Torch Vision and Matplotlib. I think it already exists. Why is it installing this stuff? Why did I let it run this then? We are at 97%. Soon, it's like 2 minutes to be done. It wants me to train the autoencoder. It already wrote it. Let me check. Accept everything. Just 10 epochs. Okay, let's see. Autoencoder reconstruction. What's happening here? Oh my god, why is it so good? What is it overfitting to these images? What's happening? Why is it so good? So just to make sure it's not overfitting, because we are testing on the training data. So now I told it to train again, but with a split. So it's just training on part of images and then testing on the other part. So if I apply this, and I really like that it can train this and it can look at the training, have training, like the AI look at the training and then it can talk to me about it. This wasn't available before. So I'm gonna update, I'm gonna accept all of the changes, which I already accepted. So if I go ahead and run, how do I run this? Okay, it's running. Validation reconstruction. It works again. You see, there is a bit of blur. Now it's a bit different than when it was reconstructing the training data. This is reconstructing training data. This is reconstructing validation data. So both of them are a bit blurred. I wonder what's gonna happen if we just train on like way more images. Download all CIFAR 10 dataset and train on it. So now our autoencoder script is running, it's training, the loss is going down, it's a bit slower, it's gonna take like 5-10 more minutes. It's not as instant as before. It has 50,000 images to train on and 1,000 to validate, I think. I downloaded whole dataset. And good thing here is that training loss is following validation loss. They're very similar. So there is no overfitting, it seems. But I have some issues with the other LLM guy because this guy just doesn't want to connect Kiro. So maybe I'm gonna use cursor, but my cursor expired, so I'm using Klein. This is also, I'm using it with Cerebras and Quen 3. It's very fast, but it's for some reason laggy because I'm using it on this cloud. Maybe I'm just gonna buy cursor subscription, I'm not sure. So the training finished here and we can see very low training loss and validation loss. Let me see first training reconstruction. I like it, I think it's good. And then validation loss, really good reconstructions as well. And then test, I still don't know what's the difference. I think validation happens during the training or something, and test is after. I don't know if this is a bit worse, but it does. Neural nets seem to have learned some things, but not enough. And this, I think this is the whole data set. So we definitely need more images to be able to fully reconstruct. We can take a look at our neural networks. So it's using convolution 2D. I don't think it's using transformer. And we have 32 times 32 times 32. So these are RGB, I'm guessing. And then we expand a little bit. So it's like a unit. And then decoder is going to be unit reversed back to 33. Maybe visual transformer would be better for this. Maybe would get better results. These are some ideas for future research, but I was just curious if I can vibe code this and test it. So I think it worked out pretty well for low amount of training we've done. Maybe next idea would be to use diffusion model or something. Or to train a diffusion model, I mean. So I will just destroy this instance, I don't need it anymore for images. So I retrained it for just like 15 minutes from scratch, the LLM, because the first one wasn't saved. And this text is so cool. So this is the prompt. Python is a great programming language because the needs of medicine used to kill fast-growing cells in our body, like a sore throat. So this might be memorized from a file, but I think it never saw files 2 times. So how is it remembering whole text, or how is it? I feel like it saw this prompt, it started typing something, and then it got locked into a single file. But I'm not even sure if this is like a file. I'm just guessing it could be memorizing file, but I think it also saw files only once. So I think I don't know if it's able. Why is it writing so well? That's my question. We see some issues here. Try out these simple recipes. That all ingredients creates a refreshing treat packed with your ingredients creates a... Yeah, it starts not to be the best here. And then the prompt is explain quantum computing in simple terms. And then it puts these empty lines. Section 1.5 cup frozen mixed berries, strawberries, and certain types of nausea. Blend until smooth and aromatic herbs offer gentle yet satisfying sustenance during times of nausea. Maybe it's remembering some text files. I told Cursor to check in the training documents if it can find word for word this text. It looks like it didn't find any match even for 30 or more consecutive characters. So maybe it's actually training well with this short amount of compute and time. Check out other videos on my channel. I will leave the code for this LLM below. You can just copy this and run the whole thing, it will run automatically. You will maybe need to update datasets if you get some asterisk errors. See you in the next video.